So with that, let me introduce myself a bit more fully. My name is Cornelia Davis. I'm a developer advocate here at Temporal. Have been here, gosh, pushing towards a year. But to give you a little bit more of my background and context, I have spent the last 15 or more years in the distributed system space. I was at Pivotal for a while, and so had the great opportunity of being part of the whole microservices movement. I worked with Cloud Foundry. If any of you are Cloud Foundry fans still or were back then, say hello in the chat panel. And the reason that I'm emphasizing that is because microservices, distributed systems, are, of course, all of us are distributed systems programmers now. And when it comes to today's topic, which is human in the loop, the whole element of distributed systems and the fact that the human in the loop is not part of the actual agentic process is actually one of the challenges that we're dealing with. And so shameless plug here, because I spent so much time in this distributed systems and microservices world, I also wrote this book. Okay, I think I've spent enough time talking about that. It's 3 minutes after the hour, so let's go ahead and jump into the program. Um, what we're going to cover really is we're going to have conversations around these four topics. We're going to talk about agents and how autonomous you want them to be and how autonomous they can be and those types of things. Then we'll talk about some of the challenges of, in particular, human in the loop. Then we're going to take you notice that my book was called Cloud Native Patterns. That's the way that I think. I think in terms of like first principles and patterns. And so we're going to talk about those things from a human in the loop perspective. And then, of course, we're going to see how temporal maps to those concepts and delivers the values that it does. And we're going to be doing demos throughout the whole webinar. So starting with that first topic, it's really interesting. As we know, we've got about a 3 or 4 year, I guess it's about a 3 year um, uh, history of LLM-based applications. And in the beginning, those LLM-based applications, from a human in the loop perspective, were very much humans in the loop. There was always a chat interface. So that's the way Gen AI really started with the launch of ChatGPT. It was the human is making a request, interacting with the prompt, and the LLM does its thing. And really the loop was it came back to the user, and the user was deeply, deeply involved in those LLM-based processes. Now, these days, you hear a lot of narrative around totally autonomous agents. The fact that we're not going to have humans at all, the agents are going to take over everything. It's going to be the Terminator and all that. No, not really. Um, but the reality is that we know that it's somewhere in the middle. And there are reasons, and this is where I'm going to drag up, and we can take a look at the results of the folks who have responded on the poll. Is that most of the Gen AI based applications, whether we want to call them agents or they're a little bit more straightforward, kind of fixed flow, they still involve humans. And there's a number of different reasons for that. And that's one of the things that we did in our poll. So let me go ahead and pull the poll results up here. Oh, where did it go? There we go. Oh, it zoomed in for me. So what we can see here is that these are the outputs from the Zoom. What I want to go in here is that what we're talking about here is this fourth panel, this fourth question. Why do you still want humans in the loop for your agents? Okay, so trust is a big one, and you were able to select as many as you wanted here. Transparency, we don't have enough insight. Liability, absolutely. We're hearing those stories where an agent goes rogue. We've heard those stories, for example, of an agent, like a travel booking agent, that said, "Here, you can have a flight for $5," and they booked the flight, and then later on, the airline tried to say, "Oh no, that was clearly a mistake." Well, they took that to court, and they had to honor the metaphorical $5 flight book. So there's definitely some level of accountability and liability, regulatory. Yeah, this is about what I expected. I expected that a lot of people would say a lot of these things. So that's the whole point, is that there's a lot of reasons for still having humans in the loop. That's what we just looked at, what you all are saying. And so here, let's start to talk about some of the challenges of the human in the loop process. So this is just a really simple fixed flow, no agentic loop in it, but we've got an LLM. It's going to, then we're going to take some action based on the decisions that the LLM has made. Then maybe we need some user interaction. Then maybe we go back to the LLM and we have some more actions. This is what we want. But as soon as we have that human in the loop, this is what we end up getting is that we might have some part of the steps that's running in one process. And by the way, this is going to be a technical talk. So I'm going to be talking about processes and all sorts of technical details. We're going to look at code in just a minute. So I've got this running in one process, the first two steps, the LLM and the action. And then I've got some user interaction, and that user interaction is not happening in the process. This is not an old school heavy client desktop application where everything is running within that client application and I'm just interacting with that process. The user interaction is coming through Slack, or it's coming through responding to an email, or yes, the user might be coming to a web page to issue their approval, but that is a separate web page. That is a separate user interaction. So we've got a separate process in the middle. And then after the user has their interaction, then we have to go to another process. Or wait, is it the previous process? Like you see how fragmented it gets from in terms of sessions. And we're going to talk about sessions more in just a bit. So this is what you end up having to do if you start thinking about solving these problems. Like, okay, I'm going to take these first couple of steps, the LLM and the action, and now I'm going to wait for user input. And remember that the third poll question was how long are your agentic experiences going to run? Minutes, hours, days, weeks. So that user interaction might be weeks away or days away. And so you're probably not going to want to keep that LLM and action, process running in memory for the days or weeks that you're waiting for the user input. So you've got to like finish this part of the app, like you've got to store your state, you need to record where you are in the process, so that when the user interacts and we want to continue the process, we can do what you see at the top, which is start the next part of the application experience, take the user input, restore the state, continue on in the processing. And what if the user never responds? Well, you've also got to have some kind of a cleanup that is going to take care of the orphans. So periodically checking the list of pending things to maybe cancel them and those types of things. So I'm sure that this is totally resonating with many of you because you've had to build these systems. And especially for those of you who are newer to Temporal, one of my ardent hopes is that you're going to see that Temporal has some very unique capabilities that are going to make this whole thing a whole lot easier. And that's what we're going to do in the rest of the hour here. Now, that picture that I just showed you was just a simple linear flow. Imagine how complicated this picture gets when you start doing it in a loop. Now you've got an agentic loop where the LLM is making decisions and the agent is executing the actions that the LLM is deciding on. There could be user interactions that are happening in many different places. And do I need to do that whole dance that I just showed in the previous one of like, let me store my state, let me wait for the user, let me resume the state, and so on. So all of that, spoiler alert, Temporal just does for you. That's why human in loop is so interesting here. All right, and so that's the punchline is here's the good news. Temporal delivers durable human in the loop. So it's durable human in the loop, not you're responsible for making it durable yourself. We deliver durable human in the loop. All right, so this is the part where we're going to start breaking this problem down into the pieces. What are the patterns? What are the pieces and parts that we need to build to put together an entire application? And what are the challenges that we need to address? Well, number one, I already alluded to this, which is that the user experience is a process that's separate from the agent. So where the user is going to interact, totally separate process. And I'm going to show you this in action in just a second. The user inputs can be needed in lots of different places in your application flow. So those pictures that I just showed you a moment ago, where in the linear kind of fixed flow, there was a spot in the middle where we said user input, or in the loop, I showed that there, you could have input in a bunch of different places. So we need to be able to address that. And now we're going to get to even more of the durability stuff, which is, well, that agentic task, the entire thing from front to back, the agent is going to do a job, let's say mortgage processing. Well, that agentic task of doing the mortgage processing is going to outlive any client connection. So I'm really getting down to stateful versus non-stateful interactions here. So the agentic task is going to outlive the client interaction. So we have to deal with that, like client connecting, coming in, and client leaving and coming back in and leaving. And then finally, especially those of you who know temporal, you know where I'm going with this, is the fourth one is that the agentic task, mortgage processing, in its entirety is also going to outlive the process that it's running in. So it's not that I can just start the process and that process is going to stick around until the whole mortgage it has been processed and has been funded. It's going to we could have upgrades, we could have crashes, we could want to like preserve resources. We don't want a whole bunch of stuff in memory that's sitting around waiting for somebody to approve a credit report, for 3 days and those types of things. Probably won't run in a single process anyway. It's all distributed systems. So what we're going to do is we're going to start peeling through these, and I want to show you kind of the solutions to the first two, which is the UX process is running separate from the agent, and let's talk about how to implement where the user input is coming in the entire agentic flow or in the entire workflow, for those of you who know temporal. So this is where we're going to jump over into some code and some demo. Let me show you what that demo looks like. It's a super simple application. I love using really simple applications and demos because it allows us to really focus on the key elements here. And so this is a very, very simple research application. When we start it up, the user can provide a topic that they want to have research on. And then we're going to ask the LLM to do some research. And we're not doing deep research here. We're just doing a very simple single LLM call. Hey, here's a topic. Please summarize this for me. So the system instructions are, hey, do a little bit of research on the topic that the user gives. Then what we're going to do when the LLM has come back with its first set of outputs, we're going to give the user the opportunity to follow up and say, well, actually do a little bit more here. So it's a little bit of a chat interface. Do a little bit more here or make it shorter or make it longer, those types of things. And we're going to allow that loop, that chat loop, to happen for as long as we need. And then eventually the user's going to be satisfied with the research. They're going to indicate that, and then we're going to generate a PDF. So you can really think of kind of that generate PDF of the tool, if you will, that this agentic application is going to use. So if you want, you can kind of think of it as that. It's an LLM and some tool use, although the LLM is not deciding. It's a fixed flow. In this case, the LLM is not deciding to generate the PDF. The human is. By the way, I really like to think of the human as one of the agents. Like we think of it here as like the LLM that's doing the research. We've got a bit of a research agent and we've got a human agent, which is actually a part of this entire agentic flow. We know that agentic flows involve multiple agents. And so I've started to think of the human in the loop as one of the sub agents that is going to facilitate getting an overall thing done. Okay, so with that, let me jump over into the demo. So you can see here that I've run the demo before. This is the interface. This is the temporal interface. For those of you who are new, I'll step you through this in just a moment. But what I have here in the upper window is I have the workflow running. So I actually don't have a workflow running. I have the agent who's on basically ready and willing. The agent isn't doing anything yet. I haven't asked them to do anything yet. And the way that that's happening is that the agent is on call, ready to go, in this temporal worker. So I'm running the temporal worker up here in the right-hand corner. And in the lower window, I'm going to go ahead and start the interaction. So welcome to the research report generator, enter your research topic, or paste an existing workflow ID. You'll see where that comes in just a moment. So I'm going to just hit enter because you don't want to see me type. There's a default prompt in there, and that default prompt is right here, which is give me 5 fun and fascinating facts about tardigrades. Okay? And so if we take a look, what's happening now is I've kicked off this workflow, which you can see is running. And in the meantime, the LLM call has finished. So it went off and it asked the LLM to research this topic. And now what you can see in this window is you can see that it's basically waiting. Now, here's something that I want to tell you if you don't know this about temporal. When it goes into this wait state, we of course have some logic that will decide whether it's going to keep it in memory. It keeps it in memory for a little while, but at some point, that worker that I showed you there is smart enough to say, you know what? We're in a wait state here, and we've been waiting for a while. So we're probably going to be waiting for a bit longer. So it actually takes those things and first it's available in a cache, moves it out of active memory, but it's still in the cache. And then if you're waiting for days and days and days, it might move out of the cache as well. But the key is that what you're seeing here, where the workflow itself, the agentic experience itself, as a logical flow, as a logical process, that is still very much alive, whether it's in memory or not. So that's a little, if you don't think about it, I mean, this is a maybe little known fact about temporal is that it does all of this stuff to actually manage your resources for you. It will take things out of memory. And so by this point, who knows, it's probably still in memory because I'm running on my laptop here. But we're waiting. We're waiting for the user input. So the first thing that I'm going to do here as a user is I'm going to query this. And you can see here that this is the output that the LLM came with. And what I'm going to do is I'm going to say, you know what, I actually want this to be a little bit shorter. So I'm going to edit, which is basically to say, hey, I want to give you some additional instructions. So let's say, please make it shorter, shorter. And now what you can see is that this little pink bubble showed that a signal came into the process. Now, if that signal came in while the process was not even in memory, no problem. Temporal says, oh, a signal? Hey, let me bring this back into memory. In this case, it was probably still in memory, but it'll bring it back into memory. It'll know exactly where you were in the process because it's taken care of all that. And then it will just continue the process. And continuing this process in this case was invoking another LLM call. Okay, so I am going to query that again. And yeah, oh, good. It came up with a much shorter result. And now I'm going to say, I want to keep this. The signal comes in, we generate the PDF, and we're done. So the agentic experience is done. So you can see how those signals are handling. Now, some of you might be thinking, well, there's nothing new there. I've been doing signal handlers and those types of things, and I'm going to show you the code in just a moment. But I'll remind you of what I just talked about as we were going through that the temporal worker, the whole architecture with the worker and the service is understanding when you're in wait states and it's doing those optimizations for you. So this durability doesn't just give you resilience, it also gives you scale. And that is pretty darn compelling. So let's take a look at the code. So I'm going to start in the workflow code. And what you see here is my overall, let's go down to the run. So here's the main process. Here's my workflow. What you can see here is that I am building up the LLM input, and then I am, yes, I am in the workflow here. So while I am in that loop, So this is the loop. It's not, I wouldn't call it an agentic loop, but remember we had that picture where it said LLM call user input, LLM call user input, and we could loop. So this is the loop that's saying, okay, while I'm waiting for the user to be okay with the final result, what are we going to do within that loop? What we're going to do within that loop is we are going to invoke the LLM, and we're going to invoke that through an activity. I'm not going to demo retries here today because we've done that in lots of other videos. If you don't understand that, then please do answer yes to the question, the poll question that's coming at the end, because we can show you all of this magic in action. I'm not going to show you every durability feature of Temporal today. But we're doing this LLM call in an activity, which gives you all sorts of resilience right there. Then what we're doing is we are reporting that we've got the research complete. And then the important part is right here. I'm highlighting it right now, which is there's the wait condition. So remember I said that the first two problems that we need to solve are that the UX is separate from the main process and that we need to identify any different place. There could be many different places where we're going to wait for user input. In Temporal, it's as simple as this. We just put a workflow.wait condition. So we identify here's a spot where we're waiting for some condition to change. And we define in there a lambda for the condition that we're going to look at. And I'm going to show you some really cool stuff about these conditions in just a bit. In this particular case, you can see that what I'm waiting for is I'm waiting for the user decision to be anything other than wait. So as soon as it's something other than wait, we're going to do something else. So where is that coming from? Well, if we come up here into the init for this class, you can see that I've initialized a class variable called user decision, and it gets initialized with a user decision of wait. And so the first time we come in, the user decision is going to be wait. And now I'm waiting for the user input. So it's really as simple as that. Once the user decision comes in, and so when I said edit, the user decision came in and it said, all right, if the user decision is that we're done and keep, great. We're going to continue processing. We're going to exit this loop. So the continue user input loop is false. And then you'll see in a moment, I'll go down to the code, we'll generate the PDF. If instead the user says edit, we're going to add their prompt to the conversation history. So this is the chat loop. And then we're going to go back into a wait state. Once we break out of the loop, as I promised, we're going to generate the PDF. And again, because that is a non-deterministic operation, we might want to be able to retry it, those types of things. We're going to do that in an activity. Okay, so that's the basic thing. So I actually talked about the second thing on the bulleted list first. Now let's move to the first thing, which is the process for the user interaction being completely separate from the process of the application itself. And that's where we have the starter. And so what you can see here is that in the starter, and let's make sure that I'm in the right place. Yep, here we go. So we've got some startup stuff here, and then we go into, we start the workflow, and then you'll notice in here that all of this is happening. I'm looking for my loop. I've lost it, but it doesn't matter. But what you can see here is that when I start the workflow, I get back a handle. And later on, when the user has input, so when you saw me type in keep or you saw me type in edit and a user prompt, what we're doing at that point is that we are sending a signal into the workflow. Now, where is that signal going? Well, the signal is going to the signal handler. So the signal handler in this particular case is right here. You can see that when that signal comes in from the output, from the outside, I'm simply setting that variable. Okay, So that's the basic functionality. I'm going to come to the back to the demo in just a moment. Now, here's just a few code snippets. The UX is separate from the agent. We talked about each one of those pieces, but here's the picture of everything that we just looked at a moment ago. I showed you where we had the wait state for the application. So we had the state variable, we had the wait that was waiting on the change of that state variable. We have a client that was issuing a signal, and then we have a signal handler that is brokering between the client side and the state variable that's causing the workflow to continue. Okay, so this is the overall picture. So once again, those of you who have been doing this a while are looking at this picture going, so what, Cornelia? I've been doing this for years, maybe decades. I've been doing signal handling. Well, I'm going to show you a few other things that are super interesting about this. With that, for those of you who are not familiar with temporal, please, the rest of you bear with me. And you might even hear me talk about it a slightly differently than you've heard before. Temporal is a durable execution service. And I'm going to continue demonstrating some of the things that fall under the umbrella of durable execution. What it fundamentally does is it supports a programming model that allows you, the developer, to program the logical flow of your application. We sometimes call that the happy path. You just program the logical flow, and all of those machinations that I showed you earlier, where you had to like preserve state because you were going to be waiting for user input. And when you got the user input, you have to like recover the state. Temporal handles all of that for you. It also handles a number of things that I'm not demoing today, which are things like retries and other resilience characteristics like that. The platform comes in the form of a durability service. So think of it as a backing service for those of you who have been doing microservices that have used things like Redis or Kafka as a backing technology. Think of it as a backing service that delivers durability. And the way that that backing service connects is via SDKs. Those SDKs are supported in all 7 of these different languages. And for those of you who don't know it, Temporal, 100% open source. Most of it's MIT licensed. There's a little Apache 2 in there because it's been around for a while. And so some of the old license stuff, just the Java, basically the Java SDK is still in Apache 2, but the rest of it is MIT licensed. Here's what it looks like from a picture. You put your logical flow in here. This is what you're building. And then temporal, by the use of the SDK is attached to the side, if you will, of your business logic. And then you've got the temporal service, which is doing a whole bunch of stuff for you. Okay. So what that means is, remember I said, yeah, you're thinking, Cornelia, I've always done this. No, like, why is this different? Well, let's overlay that. We've got those resilient services that has the SDK that's running alongside of your application, and you've got the temporal service. Well, it's exactly that that allows us, for example, to take all the stuff out of memory when you're waiting for hours, days, weeks, months. It allows you to do all of that stuff. It allows you, for example, to have, when I talked about retries, which I'm not going to demo, those retries are durable. So those retries are not implemented in your application code. They're actually a part of the durability services that Temporal gives you. So that if your process goes away, all of that retry logic, Temporal's still managing it for you. So it's different, and you'll see in just a moment. I'm going to give you 2 more demos in just a moment of some of these either failure or even normal operational characteristics that highlight the durability that Temporal gives you here. So I'm going to show you those demos so that you'll see that it isn't just a plain old signal handler, it's a durable signal handler. It's durable human in the loop. That's what we mean by that. Okay, so before I jump into those 2 scenarios where I'm going to start control seeing things in my terminal, I want to show you one other thing. If you remember here, I showed you that wait condition. It's right here at the bottom of the screen. So in this particular case, we were just waiting on that very simple flag. So when the user used the client to say, I want to edit this or I want to keep this, The signal handler was just doing a really simple operation. It was just setting one value, and uh, the lambda here is just a very simple check of that value. I want to show you something a little bit more complex, and I won't give you all of the details of this use case. If you're interested, I did a webinar a couple of months on advanced MCP, and in that I demonstrated a scenario where we were using Hacker News. We were going to hack. I basically built a Hacker News summarizer where I went to Hacker News, I asked for the latest news. I took all of those things, so I had a bunch of different things that came from Hacker News. I rendered those, and then I sent those renderings into an LLM. I did that in parallel, and then I waited for that LLM to summarize each one of those Hacker News articles so that I could generate a report at the end. So I was doing a whole bunch of things in parallel. And what we did here was we had to wait for the inputs to come back. In this particular case, the LLM was running externally. It wasn't part of this process. Go to the MCP webinar, you'll see why. I was demonstrating something called MCP sampling. And so that's I think a fun webinar for you to look at. But what I wanted to draw your attention to is that I have a whole array of stories that I'm waiting for responses on. So I've got a bunch of LLMs that are doing these summaries. And so what you can see here is that I've got in this case, it's called update. So I've got my signal handler here, but notice my await condition here. So I'm doing a workflow wait condition, and I can get very, very granular, and I can get all the way down to a particular value that is in an array. And temporal facilitates all of that. Temporal is watching things down at the one cell inside of an array, and it's waking up when it needs to, when that one cell in an array changes, so that you can continue processing. This is some super, super powerful stuff. It's not just a simple Boolean handler. You can program however sophisticated you want, and Temporal will support that. So the whole point is that this agentic process, this workflow, lives through all of those interactions. So all of those interactions that I showed you as we went along, logically, that whole thing lives, even if the processes are coming and going. So speaking of processes coming and going, let's move on. So I pointed out here that the agentic task is going to outlive the client connection. So let me demo that to you, because what you saw so far was that it could have been that I had a stateful session there. I could have just set my session timeout to 10 minutes, right? And I could have had that. But let me prove to you that that's not, in fact, what I did. So if we come back over here, I'm going to come back to temporal, and let me start another agentic process. So here we go. I'm going to start again with just using the standard, give me 5 fun facts about tardigrades, because you don't want to watch me type. If we come over here to temporal, you'll see that my research is generating and the LLM call has come in. And now it's waiting for that user interaction. Now, in this case, instead of responding right away, I'm actually going to Control C out of this. So notice that I completely Control C. So that user process, there's no stateful session here. Nothing up my sleeve, right? So now when I start that again, when I start my client again, notice that I said, enter your research topic or paste an existing workflow ID. Now, I haven't done anything fancy here. We do have some cool demos where when you're doing something like this within a chat interface like Claude Desktop, we can just say, hey, continue. And Claude is smart enough, because it knows that it's waiting for a UUID. It'll look back in its history and it'll pull out UUIDs. I'm going to be that Claude Desktop right now, and I'm going to come up here and I'm going to find that UUID. Here it is, right here. So I'm going to copy that UUID and I'm going to supply it. And you'll notice that it comes in and it says, okay, great. we've already got this running. The research is in progress. And now I can query it and see the result. Oh boy, are the demo gods not smiling on me? Did I get a new workflow? Did I give it the wrong? I gave it the wrong UUID. Um, oh no, I have a bug. I gave it the right UUID. What happened here? Oh, I see what happened. I fixed a bug earlier. You see the difference here, generate research DCH report. Let's go ahead and fix this right away. This is going to show you a really cool feature of, just found a bug in the code. It's in the starter, in fact. So I must not have saved this. Let me save this. Let's see, I've got generate research report, generate research report. Let's try that again. Control C out of that. This is how you know it's real, right? And now let me paste my UUID again. And let's see what happened. If it truly started another one, then I am going to give up. Oh, nope. It did not start a new one. I don't know exactly which one. It should be the one without the typo. It should be this top one. So let's go ahead and query. And oh, maybe not. Oh, the LLM call is there. I don't know why the query is not working, but let's go ahead and say keep. And indeed, it is this one. So my query logic must be goofed up. But you'll notice that the signal came in. So the whole point here is that my user interface disconnected, but through recording the UUID, and you would have to do this in your application. So for example, if you emailed a link to somebody and asking for their user input, you would want to have that UUID embedded as a part of the link that they click on when they're going to give that approval. So I think you kind of follow that. So, okay. So that is what we did here. So what we did was we killed this client, and then we reestablished that connection and the signal handling went through. Now, the next demo that I want to show you goes a little bit beyond that. In fact, I'll come back to that slide, is I'm going to take this picture and I'm now going to kill this. I'm going to kill the process itself. So let me go ahead and start a new workflow because I fixed some typos somewhere in there. We're going to go with our standard query. Let me come back over here. And we should be seeing a new, what's going on here? I have a bug somewhere.
Cornelia, some people in the chat are saying line 19.
Line 19. Thank you. Let's do a little live coding here. Line 19 in my workflow? No, in my starter. So workflow ID, yeah. So I have, oh, it's still there. I thought I fixed this. Okay, so let's go ahead and save that. Let me double check. Okay, so let me Control C out of this. Try again. Thank you for the live debugging. I'm a little off today. Apologies for that. Okay, so let's see if this does indeed start a new workflow. Yes, yay, thank you. There's the new workflow. So we're doing the LLM call at the moment, and it's done. So I can query this. And sure enough, there we go. There we have the output of the LLM. Thank you all for the debugging help. And now, as I promised, I'm going to kill the process that's running the workflow. So I'm going to come up here to the top. I'm going to Control C out of this. No process running at all. So there's actually no connection from the client either because there's nothing to connect to. But you'll notice here in the UI that the logical process hasn't gone anywhere. So this is all about the logical process. Temporal's caring for that logical process for you. You're no longer tethered to individual physical processes. yet your application logic and your application semantics continue. So now let's just say that's still down, and I'm going to say keep. I'm going to send that signal in, and you'll notice if I come over here, the signal came in. The process that's handling the signal is offline, but the signal is durable. So you see what we mean by durable human in the loop? The signal is durable. So now I'm going to come back here. I'm going to start up the process, and you will see immediately it kicks in and says, okay. And by the way, if we were waiting for a long time for that process to come back, you'll notice that the process was gone. Remember I said how it might be out of memory? Well, in this particular case, because I started a whole new process, we needed to reestablish that entire application state, and it happens in milliseconds. We established the entire application state and then picked up where we left off. So that is right there what we mean by durable execution. You've seen lots and lots of different examples of that. Okay, with that, I'm going to close us out and I will move into Q&A in just a moment. So the whole punchline, of course, is that remember I said that this is what we want, but I showed you that ugly picture of all the things that we'd have to do to actually get human in the loop working. With temporal, this is actually what we can have. And that's why I'm here. That's why I'm at Temporal, because it is mind-blowingly powerful when you start to understand it. So with that, I thank you for your attention. I do want to share with you a couple of other things. So this module that we talked about today is one small module in a larger workshop that we are running on November 18th in San Francisco. We are starting to get close to capacity, but there are still a few seats available. It's going to be at the JW Marriott at Union Square area in San Francisco. You can see there's a QR code and there's a bit.ly there. So please, if you're interested in coming, please do come. It is costing you a huge amount of $10. And if that's too much, use the code webinar100 and you can get it for free. We're going to feed you. We're going to give you libations at the end of the day. And we're going to spend a whole day doing the types of things that you just saw in this webinar. And then I'll come back to this slide in just a moment while we do QA, but I also want to share with you another couple of resources. So we have an AI cookbook, which you can see there. You can also find it by just going to our documentation page, and there's a tab at the top that says AI cookbook. And it has a whole variety of patterns. It's still relatively limited, but we're adding patterns all the time. In fact, there's 3 PRs that are in review right now to add 3 new recipes to the cookbook. One of those, by the way, is a human in the loop recipe. So you're going to see that in the cookbook. The other thing that I wanted to do was highlight a blog that we have on our website, which is around ambient agents. So remember, if you remember the pendulum picture at the very beginning of the slides, and I said all the way to the right-hand side is, totally autonomous agents. Well, spoiler, in that example, which is available in Git as well, in that example, there's an opportunity for the human to come into what could be a totally autonomous experience. There is the opportunity for the human to be monitoring it and say, oh, hit the brakes. Let's do something different. So would love for you to take a look at those couple of resources. There's another poll that's up if you want to go ahead and answer that. And I'll come back to this in case some of you want to come to the demo. And with that, let's go to Q&A.
Okay, we don't currently have any new Q&A. We did answer some throughout,
Awesome.
but we'll leave it open for a minute or two to see.
Yeah.
And we will be sending out the recording in the deck and these additional resources linked along with that webinar, the MCP webinar, and that'll be by Monday, likely earlier.
Yep, cool. And for those of you who are still on, the second poll question is, what other topics would you want to see us cover? That is a really great opportunity for you to give us feedback. We have, in many cases, almost always taken that input. And Hannah is my partner in crime on these webinars. And usually within the first hour after one of these, she's sending me a note and saying, hey, you interested in doing a webinar on XYZ? So this is a really great way for you to get topic coverage.
Second to that, we definitely love hearing what would be applicable and helpful. So definitely
Yeah.
answer that. And with that, I think we are all set. Thank you so much for joining, Cornelia. Thanks for doing it again
Okay.
with me.
Thanks all.
Have a
Bye.
good day. Bye.